Hey everybody, welcome to week number three's recording, where we're going to be looking at the normal and continuous distribution. And the assignment this week is titled Predicting Supply and Demand. So this week, your company is progressing toward making more decisions based on data and statistical reasoning, instead of hiring a third party to make predictions about the forthcoming quarter supply and demand. They've approached you and your data analysis team. Um, Complete the steps below and make a recommendation to the management team. So the assignment this week is going to have you looking at trying to predict how many widgets your company will need to order to meet the demand for the next quarter. So let's take a look at your actual assignment here. Is similar to the last one. I give you a variable codebook. There is a new variable in our data set this week, the widgets month, and it is the average number of widgets in thousands produced per day for a single month. And under this here, I described a couple of new functions that we are going to use this week. The first one is called QQ plots, and those are quantile plots. And basically, what it is a chart to show you the normal distribution of the data, or if the data itself is normally distributed, I should say. And the way that it works is that it will plot both of the quantiles against each other, against a normally distributed line in a chart. But that is something that we will cover a little bit later in the lecture. The other two functions are called CDF normal and IDF normal. CDF normal stands for the cumulative distribution function, and the CDF normal will give you the probability that a random variable within a normal distribution of data will be less than a quantity that you put into the function. Whereas the IDF normal is the inverse distribution function, which is similar to the CDF function, only you put a probability value into this function and it gives you back a number. So let's just hop right into the first question here. Describe the distribution of the average daily closing price, which is stock underscore month, as well as revenue, which is rev underscore millions. We've already done this a few different ways, but let's just hop right into SPSS. And we can do the Explorer. So let's go ahead and put stock month and rev millions in here, and make sure that we have the histogram checked off. And we are only going to look at the distribution of the data to describe it. So I'm going to head and turn off the statistics, and I'm only going to be interested in the plot. So I'm just going to select plots and click OK. So I have a very small sampling of data, which, like I mentioned in the past, is just a random sampling. So anything that you see in this recording here will not be what you will see. But I have my histogram for stock month, as well as my histogram for revenue millions. This question is just asking you to describe the shape and the modality of both of these histograms. So just a few words to answer this question is totally fine. All right, question number 2, create a histogram and a normal QQ probability plot for widgets sold, which is widgets underscore month, and describe the distribution of this variable. So we will do the same thing again. I'm going to analyze and explore. Go ahead and reset this real quick and add in widgets underscore month. Now for this one, it's asking me for a QQ plot as well. So we're going to go and just build a histogram out from here. So that way I will get my widgets month histogram. And then I'm going to go and use the specific QQ plot function, so that way I can take a minute to show you that as well. So in the analyze descriptive statistics, I have a QQ plot function, and I'm going to add in my widgets month. And looking at this histogram here, it is fairly normally distributed. It is skewed a little bit, but for this, I am going to just leave it as a normal distribution here. And for this, there's nothing else you need to do. Let's just go ahead and click OK. And I will get my QQ plot. So the line that I mentioned earlier in the recording, the line of normalcy, is this black line that goes through the middle of your QQ plot. Let's see if I can make this bigger. That's fine. Like I said, this is the line of normalcy that I had mentioned. In all of these items, or all of the dots here, are each of your data points for widgets underscore month. And what is happening is you can see it has kind of a nice S shape to it, which is what I would expect. And a fairly nice S shape is indicative of a normally distributed set of data, as well as if your plots fell very nicely along this the line of normalcy in the middle of your QQ plot. The ones that fall very outside, like these couple here and these few here, when we run a box plot in one of the next questions, you'll see that these are most likely the outliers of your data set. So I have my histogram and my normal QQ plot. Describe the distribution of this variable. From my histogram and my normal QQ plot, I will say that widgets underscore month is a normally distributed variable in my data set with a unimodal shape, because the histogram only had one bell to it. So question number 3 is asking me if widgets underscore month is normally distributed, meaning that I'm able to use the data in the widgets underscore month for prediction making questions. And because my data, my widgets underscore month variable is normally distributed, the answer to this question is yes, I am able to use widgets underscore month as a predictive variable. All right. Next up is question number 4. I mentioned that we'll most likely create a box plot so that we can see the outliers. So let's do that next. Create a box plot for widgets sold. And are there any outliers in the data, and how do I know? So I'm going to go ahead and close this chart. And go back to SPSS here. And I'm going to use my chart builder to go ahead and build a box plot for widgets underscore month. And we don't need to make any changes to anything for our chart options, our element, or anything like that. So let's just go ahead and add widgets underscore month and click OK. So in my data set, I only have one outlier here, which is 75, or the value of 75. One of the ways that I can calculate this manually is by using the interquartile range. The design of the box plot is fairly standard in statistics, and it will show you the outliers of quartile 1 minus 1.5 times the interquartile range, as well as any of the items in quartile 3 plus 1.5 times the interquartile range. And as I mentioned, that 1.5 times the IQR, or the interquartile range, is fairly standard, and it's not really something. So you can look at a box plot, and unless it tells you otherwise, you can assume that the outliers that it's showing are outside of 1.5 times the interquartile range. So let's go on to the next question here. Calculate the mean, standard deviation, and median for widgets sold. Compare the mean and median. Is there a difference, and what does this tell us? All right. So for the purposes of this recording, I'm just going to do this first part here. Calculate the mean, standard deviation, and median for widgets sold. And we can do that in one quick and easy step here by going up to widgets_month and then just running our descriptive statistics. So we have our mean, median, and standard deviation. These two pieces of information, the mean and the standard deviation, if you have a piece of paper next to you, I would write these down. You're going to need these for the next 3 or 4 questions. And just to have them handy, it's a lot easier just to have them written down and next to you. So for my data set, widgets_month, I have a mean of 49.75 and a standard deviation of 16.7. Question number 6. Using the mean and standard deviation of widgets sold, as well as the characteristics of normally distributed data, which we have already determined that widgets_month is normally distributed, calculate the probability that your company will sell 45,000 widgets in the next quarter. And in the earlier part of this recording, here, let's go back into where we need to be. There we go. In the earlier part of this recording, I had talked about the CDF and IDF functions. We're going to first use the CDF function of 45, or with the 45,000 widgets. One thing to keep in mind, the widgets_month is giving you the number of widgets in thousands. So you need to pay fairly careful attention to make sure that you only enter 45 into your calculation and not 45,000, or you'll have some significantly skewed data. Some significantly skewed calculations, not data. So we, to do this, are going to use the compute variable function in SPSS. This is a very handy function which we will use a lot for the remainder of the semester. But let's go ahead and click on transform in compute variable. And here is the window. So what it's going to ask you first is for a target variable. So doing this, it's going to calculate a new variable in your data set for you. So I am just going to simply name it P45, which is the probability of 45,000 widgets. And down here in my function group section, I'm going to choose CDF and non-central CDF, so that way I get all of my distribution functions. And in my actual function list here, I'm going to scroll down until I get to CDF normal. So SPSS is great that it gives you what the function is, as well as the pieces of data that it needs to actually run its calculation, in a short little description on what the function actually does. So to insert the function, go ahead and click this small little arrow here, and we'll put it up in the top. And as I mentioned, the piece of information that goes in this first one is going to be the quantity, and we are interested in 45. Remember, not 45,000, because the mean that I have calculated of 49.75 and 16.7 are calculated from widgets in thousands. So I have 45. The next piece of information it asks me for is my mean. So I'll go ahead and put that in here of 49.75. And the last piece of information it asks me for is my standard deviation, which is 16.71. So now that I have all of that in there, I'll just go ahead and click OK. And now you see that in my output window, it computed a new variable for me. I'm going to go over to my data set, and now you have this P45 column. So don't worry that it added it, however many cases that you have in your data set. The important thing is that it's all exactly the same. So the probability. All right, sorry about that. I had to pause the recording for a quick second. Back where we left off, the P45 variable that SPSS is now inserted into your data set. The probability of selling 45,000 widgets in the next corner is 0.39 or 39%. So the great thing about the CDF function is that it shows us, or calculates for us, the probability of something happening up until a point. So it is 39%, or the probability is 0.39, or 39% that we are going to sell 45,000 widgets in the next quarter. But the next question on your assignment is, what if we want to calculate what's the probability that we will sell more than 70,000 widgets in the next quarter? And that can be calculated using the same CDF function. So I'm going to go ahead and pull up my compute variable one more time. Just change this to P70 to give me my probability of 70,000. Be sure to change your quantity to 70. But the one other change that we're going to make is to take the inverse of this CDF calculation. We're going to do this because the CDF function, like I just mentioned, gives us the probability of something happening up until a point. So the CDF function will tell us what is the probability of us selling 70,000 widgets. And the question is asking you what is the probability of selling more than 70,000 widgets. We all know that the probability can't be more than 1.0 or 100%. So if we take the calculate the probability of something happening up until 70,000, taking the 1 minus of that, or the inverse, will give us the probability of selling more than 70,000 widgets. So I will go ahead and click OK. And now we have this in our output as well. P70 equals 1 minus CDF normal. Go back to my data set. And the probability of selling more than 70,000 widgets is 0.11 or 11%. So now we have calculated probability of something happening up until a point. We have now calculated the probability of something happening after a certain point. What if we wanted to calculate the probability of something happening between 2 points? We can very easily also do that with SPSS. For ease of some values that you already have. The question is asking you what's the probability of selling between 45,000 and 70,000 widgets. Just scroll down a little bit here. So we already have the P70 value and the P45 variable. So we just need what is actually in the middle. So we can do that just by looking at our data set here. That probability would be 0.28 or 28%. Or if you would like to use the compute variable, you can certainly do that. I'm just going to do this P underscore range. And you'll see now you have your P45 and your P70 variables here, which can be used and inserted into your numeric expression. Let's do P70 minus P45 and click OK. Go back to our output here. And we have the probability of 0.28. Awesome. All right, so question number 9. Company managers want to know how many widgets they would need to sell to achieve more than half of probability estimates. So the question you need to ask is, what is more than half? 50.0000000001 is technically more than half. But as a rule of thumb, when you're asked for majority probability or something similar like majority sake, more than half, I typically just use 51% or 0.51, and that's what I would like you to use here. I mentioned in the beginning of the recording about the IDF function, so we're going to look at that here because we have a probability value of 0.51, and we also have the mean and standard deviation of my data set already. Let's go ahead and calculate a new variable of I51. Take this out of here. In my function group, I'm going to scroll down to the inverse DF function group, and from the list, select the IDF normal. Again, SPSS gives you the same thing, the components of the actual function, as well as a description. So we are going to insert 0.51 along with my mean. Let's go back over here. This is why I say it's easier just to have it written down. I'm just going to close this real quick. It'll make it a little bit easier. Come back over here. Compute variable. Maybe I51. And you can also type it in if you know the command that you want to run. It's IDF normal. And it's going to be 0.51, comma, my mean, which is 49.75, and my standard deviation of 16.71. And click OK. So in my output, I don't have any errors. You can go back to my data set here, and the value I get back is 50.17. You can also, if you so choose, in your I51, you can multiply this by 1,000 if you would like to get an actual number, or you can just know that the calculations that you were working with or the variable you were working with was in thousands. So the number of widgets that would come to a 0.51 or 51% probability that I'm going to sell is going to be 50,170 widgets. All right. So moving on to our next question. Our next question here calculate how many widgets are sold 2 standard deviations above and below the mean. All right, so we have our mean of 49.75 and our standard deviation of 16.71. This is just a simple calculation that you can do by hand, or if you so choose, you can certainly use SPSS. The great thing about it is that because this is just basically like Excel or using a calculator, I'm just going to make a new variable, which is going to be plus 2 standard deviation. So I have my mean of 49.75 plus 2 times 16.71. Click OK. Go back to my data set. So my value of plus 2 standard deviations is 83.17 or 83,170 widgets. And then if I do this one more time, I'll do this one minus 2 standard deviations. Go ahead and change this to a minus sign and click OK. Oops. Now I have my minus 2 standard deviations of 16.33 or 16,330 widgets. What does this finding or information mean? I'm going to leave that part up to you. I would reference our earlier lecture or the slides that I posted that talk about the 66, the percentage rules of a normal set of distributed data. And the last part of the assignment here is this advise and recommend section. I had gotten a couple of questions from the last 2 assignments on what this section is. This is the narrative section. This is the part where you actually have to write. What I added this little note down the bottom here, an important reminder for answering questions in this section is to write your answers in a way that is consumable by a non-statistician, because basically what you're going to be doing, what you'll be learning through this program, is how to present data and how to present information in a way that it is easily consumed by someone who is not an expert in the field. So, like I said here, this part of the assignment you should write in a way that is easily consumable and understood for a client. If your client is a management team for a large corporation, then you should write your advice and recommendations in a brief and professional manner. Management teams do not want to read long statistical reports. You should give your recommendations briefly while still supporting them with some of the statistical analysis that you ran to support and back up your answer. So your 3 questions, and your answers for these only have to be just a few sentences. I'm not looking for anything long. Summarize how you would likely believe the company will fall below selling 45,000 widgets, above selling 70,000 widgets, and selling between 45 and 70,000 widgets. So basically, in this question here, I'm just asking you to take your answers to questions 6, 7, and 8, and taking the answers and turning them into words. The next one, choose a value for sales probability that meets your understanding of optimistic in the context of this assignment. So basically, I'm asking you to kind of do question number 9 again. You have, or you will calculate the plus and minus 2 standard deviations from the mean, which will give you a very wide percentage probability of actually being able to produce and sell that amount of widgets, along with a lot of the other information. Key pieces of information I'm not going to give away, but things that you have calculated and looked at in this assignment will help you pick an optimistic goal, um, or an optimistic sales probability that you will then, in question 13, use the IDF normal function to return the number of widgets that you feel as if your company should strive to produce and sell in the next quarter. And as always, at the end of this assignment here, I have some information, the hints and information that will guide you on your way if I wasn't clear in this recording, or you would just prefer to use the recording as kind of an add-on and would much rather prefer to just read than listen to my wonderful monotone voice. This information is at the end of the assignment for you. So if anyone has any questions on this assignment, please feel free. Shoot me a message or post a question in the course question and answer discussion board, and I will answer them as promptly and as quickly as possible. I'm working on grading the last 2 weeks of assignments, and I should hopefully have those done and posted for you by Friday or Saturday at the latest. That's it for this recording. Everyone, have yourself a great week, and we'll talk soon.